Hi everyone, welcome to section 9.6. 9.6, analyzing functions, successive differences. It's the last section in this chapter. We're going to start off by just identifying functions. Notice under the objective it says we're going to identify linear, which looks like a straight line, quadratic, which we know is a parabola, and exponential will be the only new one. So I've got the figures right underneath here. There's not even really anything to write. Just make a little note. Remember, we talked about linear functions this year. Y equals mx plus b is slope-intercept form. The b is the y-intercept. The m is the slope. We know what that looks like. It's linear. It is a straight line. Quadratic looks like a parabola. We know what that looks like. Notice up here I've got the standard form of that equation. You also, whoops, there we go. You could put that in vertex form if you had the opportunity to do so, but we know it looks like a parabola. It either opens up or down based on our a value. Exponential is the newest one. We're going to just call this exponential. We can always have variations like everything else, but notice the equation. Y equals a times b to the x power. This one's unusual because the x is in the exponent, not sitting out somewhere as one of the variables like the other two equations. There's no real good shape for that or explanation for it. There's no name for an exponential graph other than exponential, like we have parabola for a quadratic. But notice it starts off low, really close to 0. As you read it across from left to right, it gets larger and larger at an increasing pace. It gets steeper and steeper as you go across the x-axis. So note those three equations. We're going to use those later on. So first of all, it says to graph the sets of ordered pairs, determine whether they represent a linear, a quadratic, or an exponential function. So I think we really only need to do one of these for practice. Let's skip A. Do A on your own if you like, but let's talk about B because of the ordered pairs. So notice how we've got 5 ordered pairs. They're all in the set notation with the swirly brackets. So -2 1/4 is really close to the x-axis. -1 1/2 is a little bit higher. Over 0 up 1, 1, 2, and 2, 4. Do you see that if I connect these, it's going to be a curve? It's definitely not linear, right? If I connect these guys, it looks like that. That's all I can go on. Make sure you put arrows on either end. So it's definitely not linear. Does that look like a parabola or parabola potential? It looks like it could have potential before I kept that left side going. You have to kind of go with the ordered pairs I give you. So if it looks like a parabola, I'm going to give you so it looks like you've got a vertex with things going either up or down. So our only other option really is this is an exponential graph. It gets increasingly larger as we go across from left to right on the x-axis. So now let's talk about identifying. So notice the practices on the bottom. I give you XY tables. Some people don't like XY tables going across like that, by the way. That's how the book does them. I think on our practice problem, I put the XY table up and down. But we can identify. So instead of me giving you the graph or put these ordered pairs on a graph and identify, I'm going to say, look at the actual numbers for the x and y values. So what you are going to do is you are going to find the differences of your y values. You're going to assume that all of my x values increase by 1. I'm not going to try to trick you with the x's. I'm just going to look at the y's. And here are the 3 things that can happen. If all of your first differences, the first time you do it, are equal, you've got yourself a linear function because we've got a constant rate of change. So first differences are equal, you've got a linear function. If the first differences aren't equal, you keep going. So let's actually do problem 2A down here so that we can see. Actually, let's do 2B. So 2B, notice my x's are all increasing by 1. So I don't even worry about the x's. I want to know the differences of the y values. So to get from this y value, -3 to -7, -3 to -7, that's a -4, right? To get from -7 to -9, that's going back 2 more. To get from -9 to -9, that's a change of 0. And to get from -9 to -7, we're adding 2. Well, if this were linear, all of those numbers that I just wrote in would be the same. -4, -4, -4, -4, or whatever it might be. So this is not linear. So now I'm going to keep going. I'm going to take those numbers that I just wrote down, that -4, -2, 0, 2, and I'm going to do second differences. If all my second differences are equal, oh, you can hardly see that. Let me try a different color. If all my second differences are equal, it's a quadratic or a parabola. So to get from -4 to -2, would you agree that I add 2? To get from -2 to 0, that's adding 2. To get from 0 to +2, I'm adding 2. It worked out so that that second set of differences, and differences just means we're going to subtract, right? I'll put that up here, subtract. When I do that, and if you're going to your calculator, by the way, you're going to think of how do I get from the first to the second, or take -7 minus -3. Take the second number minus the first. So since my second differences are all equal, this, if I graphed it like I did up in that example before, would look like a parabola, or it would be a quadratic equation. So let's skip up to 2C. Let's do, oh, I forgot to say the last important thing. I forgot. If none of that happens, if your first differences aren't all the same, if your second differences aren't all the same like ours just were, then you check the ratio of the y values. So if none of the above is true, we're going to set up ratios of y values, and if those are all equal, we can cross multiply to check a proportion. We've got ourselves an exponential. Sorry about that, I almost forgot. So your first thing is to look at first differences. Your second thing is to look at second differences. Your third thing is to set up proportions and check them. So now let's skip over to 2C. So first of all, I always check. I don't even need to, but does everybody agree that every time my x values go up by 1? I just like to know that that's the same. I don't even have to worry about that. I will give that to you every time. I'm not trying to trick you. So let's do our first differences. Don't answer that.
Welcome to the short-held button.
Ignore this. Sorry, technical difficulties. First differences, to get from 8 to 4, what do? That's going down 4, right? To get from 4 to 2, that's going down 2. To get from 2 to 1, that's subtracting 1. And to get from 1 to 0.5, that's subtracting 1/2 or 0.5. So my first difference is these all numbers that I wrote in green are not the same. So I know that this is not linear. Not linear. So now I'm going to go over to second differences. I'm going to check these. So to get from 4 to -2, isn't that adding 2? Think on a number line. To get to -2 to -1, well, that's adding 1. To get from -1 to -1/2, that's adding 0.5 or 1/2. So my second differences are not the same. So this is not quadratic. So now my last thing that I'm going to do is I'm going to check, I got that none of the above, so I'm going to check the ratios of the y values. So when I set this up, I'm going to set it up as the second over the first. So y values only. So I'm going to take these two guys right here, and I'm going to set myself up a ratio. So I'm going to set up a 8/4 over 8. I guess I should just write this right underneath there. And then I'm going to set up another one. I'm going to set up a 2 over 4. And then I'm going to set up another one. I'm going to set up a 1 over 2. And I might as well set up one more, right? A 0.5 over 1. Are all of these things equal? If you type 4 over 8 into your calculator and turn it into a fraction, what do you get? If you type 2 over 4 into your calculator and turn it into a fraction, what do you get? 1/2 we know is. How about try 0.5 divided by 1? What is that as a decimal? So all of my ratios of my y values are equal. So this is exponential. All ratios are equal. We could have also set this up where we cross multiplied, like 4 times 4 is 16 and 8 times 2 is 16, so I know those guys are equal. I could do that. 2 times 2 is 4, 4 times 1 is 4, so I know those two are equal. 1 times 1 is 1, 2 times 1/2 is 1, so I know those two are equal. So we could check by cross multiplying if you prefer that method. So this is just taking an XY table. You could, of course, graph those points if you want to and just look at the shape of it, but I'm going to expect that you understand finding the first differences and the second differences. So last but not least, writing equations. This is where you got to really put on your thinking cap because these ones get a little tricky. Linear and quadratic are okay. You have to think a little bit harder for exponential. So first of all, decide if it's linear, quadratic, or exponential. So start by finding your first differences. If those are equal, stop. You know it's linear. If they're not, keep going and find your second differences. If they're equal, stop. You know it's quadratic. If none of the above is true, check the ratios and you know it's exponential. So you have to do that above. Then use your basic equation to start. So I tried to give you some hints in here. If you decide that you've got yourself a linear equation, you're going to start with the equation y equals mx plus b, which is what I gave you on the top. And the first difference, the same number that you got, will be your slope or your m value. So all you've got to do is figure out your b. We've done this before in semester 1. I hope you remember how. We'll do an example probably. If you decide that you've got an equation or a quadratic equation, you're going to start with just the most basic parent graph, y equals ax squared. And we're going to have to figure out, I should put this. So over here, we're going to need to figure out b. Figure, I'm just writing, oh my gosh. Hold on. There we go. Oh my gosh. Hold on. Definite technical difficulties today. Sit tight for just a second. Oh my gosh. There we go. So we're going to have to figure out b. For the quadratic, we're going to have to figure out a. And last but not least, if it's exponential, you've got y equals ab to the x is your starting equation. And you know something, your common ratio will be your b value. So we're going to have to figure out a. All right. So let's do a practice. I think we're going to kind of work our way into these, and we'll kind of use this as our guide. But let's do 3A. So first we've got to decide if it's linear, quadratic, or exponential. So we're going to have to start by finding first differences. So my first difference, my x's all go up by 1. How about my y's to get from 11 to 7? That's subtracting 4, right? 7 to 3. 3 to negative 1. Think on a number line. -1 to -5. So would you agree that my first differences are equal? If my first differences are equal, what kind of equation am I working with? I'm going to start off with my equation, mx plus b. And what do I already know because I just did the work? First difference is my slope. What was my first difference? My equal values for everything. So I know that I've got y equals -4x plus b. Because my -4 was my first difference, and I put in the notes up here, your first difference is your slope. So now we just have to figure out b. Well, I am telling you that I can see b from my table. Remember how when we looked for our x-intercepts, our roots, our solutions, our zeros, it was when the y value was 0, we would take the x value. Well, guess what our y-intercept is? How do you identify it? Look for when x is 0. This is our y-intercept. So I'm going to be able to just take this 3 right here and put it in for my b. So my final equation is -4x plus 3. Wasn't too bad, huh? So let's do, let's skip B, let's go to C. So C, first thing I'm going to do is I am going to find my first difference because I need to decide if this is linear, quadratic, or exponential. So my x's are all going up by 1. My y's, how do I get from 32 to 18? It's definitely subtracting, what is that, 14? 18 to 8, subtracting 10, already I know it's not linear because I don't have the same numbers. 8 to 2, 2 to 0. So it's definitely not linear, so let's check our second differences. -14 to -10. That's adding 4, right? -10 to -6. And remember, if I'm going to a calculator, I would do -6 minus -10. That gets me that +4. So if you're figuring this second difference, you do -2 minus -6. Nice. My second differences are the same, so I know that this is going to be quadratic. I didn't tell you anything about the quadratic except start with y equals ax squared. So what I'm going to do is I'm going to be sneaky. I'm going to pick a point other than 0, 0, and I'm going to put in an x and a y. So I always try to pick the easiest one. Let's pick this. So let's put in to equation. So for the x, I'm going to put a -1. For the y, I'm going to put in a 2. If I put in an x and a y, that means I've only got an a left. I could figure out what a is equal to. So order of operations says we do squaring before we multiply by a. So 2 equals, trick question, what's -1 squared? +1, right? So when I divide both sides by 1, what do I get for my value of a? We just found a, which means I'm going to put that a right in here, and my work is done. My final equation is going to be y equals 2x squared. There is no little helpful hint like when we find that second difference that goes in somewhere. It's just you've got to put in an x and a y. You can't use 0, 0 because if you put in 0, 0, you wouldn't get anything. So you have to use something other. All right, last example. Our values of x's are all going up. Our values of y, to get from -1 to -8, I think that's subtracting 7. -8 to -64 is some big subtraction. I know this is definitely not linear. What is that, -56 maybe? -56. -64 to -512 is -400 and something, 88. And I didn't even do the math to get from -512 to -4096. It would be -3000 and something crazy. Figure it out, I don't even know. But I know this is not linear. So let's check our second differences. To get from -7 to -56, what is that, -49? To get from -56 to -488, that would be -432, something that's not the same. So this is not linear. This is not quadratic, which means I'm going to set up a ratio and double check it. So I'm going to take this and set this up, second over the first. I'm going to take this and set it up, -64 over -8. I'm going to take this and set it up, -512 over -64. If I simplify these, will they all come out the same? And I could do the last one too, I guess, huh? -4096 over -512. So it looks to me, if I cross multiply or if I simplify each one, looks to me like they all come out to 8, 8, 8, and 8. So this is definitely exponential. This is the hardest one to do. But remember in the notes I told you with exponential, the common ratio is my b value. So I'm going to start off with this ab to the x. So already I can put this 8 that I kept going in for that equation. So I know I've got y equals a times 8 to the x power. So that's not bad. I'm good so far. So now I'm going to put in an ordered pair, just like I did for quadratic. Don't use 0, 0, but I could use 0, -1. Put into equation. So x is 0 and y is -1. So -1 equals a times 8 to the 0 power. Well, what is 8 to the 0 power? You better remember this one. Anything to the 0 is 1, right? -1 equals a times 1. Whoops. So what must a be equal to? So now I just figured out this a. I'm going to go back up here and stick that in there. And I'm going to have y equals -1. I'm just going to put it in parentheses, times 8 to the x power. I have to separate the -1 and the -8. You could put a times dot in between them. The x is on the 8. The -1 is out in front. And remember, we wouldn't times those guys because I have to do the x power exponents before I multiply. So here's my final answer. This one I think is the hardest one, but we'll muddle through them. We'll take these guys kind of slow. So here's what I would like to know from you. What type of equation if, write down number 1, what type of equation if the first differences are equal? Number 2, what kind of equation if the second differences are equal? And number 3, what kind of equation do you have if the ratios are equal? And write that equation. First decide if it's linear, quadratic, or exponential, and then use the examples that we did to write the equation. So I'm looking for an actual y equals something equation. All right, have a great day. We'll talk to you next time.